Alright, so in this problem, I have 2 to the power of x minus 3 to the power of y is equal to 7. So I want to find the values of x and y. So for my solution, if I have something in the form 2 to the power of x minus 3 to the power of y is equal to 7, I'm going to rewrite 7 as 4 plus 3. So now I have 2 to the power of x minus 3 to the power of y is equal to 4 plus 3. And the reason I did this was because 4 is the same thing as 2 squared. So now I get 2 squared plus 3. And notice how I have something in the form 2 to the power of number minus 3 to the power of number is equal to 2 to the power of number, and I also have 3 to the power of 1. Now from here, I'm going to group the powers of 2 together and group the powers of 3 together. So I'm going to subtract 2 squared on both sides. So I get 2 to the power of x minus 2 squared minus 3 to the power of y is equal to 3. And then I'm going to add 3 to the power of y on both sides. So then these two cancel out, and I get 2 to the power of x minus 2 squared is equal to 3 to the power of y plus 3. Now, for my left-hand side, I'm going to factor out 2 squared. So, actually, instead, I should say I'm going to divide by 2 squared. So, 2 to the power of x divided by 2 squared is equal to, well, if I have something in the form a to the power of m over a to the power of n, this is equal to a to the power of m minus n. So that's the same thing as 2 to the power of x minus 2, and then I have this minus 2 squared divided by 2 squared is 1. And now this is equal to, from on this side, I'm going to divide by 3. So I have 3 times 3 to the power of y divided by 3. 3 is the same thing as 3 to the power of 1, so I get 3 to the power of y minus 1. And then 3 divided by 3 is equal to 1, so I get plus 1. Now from here, if I have something in the form a to the power of m times a to the power of n, this is equal to a to the power of m plus n. So 2 squared times 2 to the power of x minus 2, this is equal to 2 to the power of 2 plus x minus 2, and these two, and 2 and negative 2 cancel out, so I just get 2 to the power of x. So 2 squared times 2 to the power of x minus 2 is 2 to the power of x, and I have 2 squared times negative 1, which is negative 2 squared, and this is equal to 3 to the power of y plus 3. So I'm just checking if we distributed, if we factored out right, and it looks like we did. So now going back here, let me rewrite this. I have 2 squared times 2 to the power of x minus 2 minus 1 is equal to 3 times 1 plus 3 to the power of y minus 1. And notice how 2 squared, that's equal to 4, is an even number, and 2 to the power of x minus 2, well, 2 to the power of any number is even, and an even number minus 1 is going to be odd. So we have an even number times an odd number is equal to 3 is an odd number, times 3 to the power of any number is an odd number, plus an odd number plus 1 is an even number. So you have an even number times an odd number is equal to an odd number times an even number. Now, what I'm going to do is I'm going to set the odd numbers equal to each other, and then the even numbers equal to each other. So this gives me two equations. I get 2 squared is equal to 1 plus 3 to the power of y minus 1. And I also have 2 to the power of x minus 2 minus 1 is equal to 3. So let's first start with this equation. this is going to equal 4 is equal to 1 plus 3 to the power of y minus 1. And this means that 3 is equal to 3 to the power of y minus 1, meaning y is equal to 2. So the value of y is 2. Now for 2 to the power of x minus 2 minus 1 equals 3, I'm going to first start by adding 1 on both sides. So I get 2 to the power of x minus 2 is equal to 4. And now 4 is the same thing as 2 squared, so I get 2 to the power of x minus 2 is equal to 2 squared. And this means that x minus 2 is equal to 2. And if I add 2 on both sides, these two cancel out. And I get x is equal to 2 plus 2, which is 4. So my solution is x equals 4 and y is equal to 2. Alright, so in this system of equations, I have x squared minus y squared is equal to 28, and x times y equals 48. So I'm given two equations. Let's just say that this is equation 1 and this is equation 2. So what I want to do is find the value of x plus y. So what is the value of x plus y? And finding this is fairly simple when we find the value of x and the value of y. So to start, what I'm actually going to do is I'm going to use my second equation here. So equation 2 is x times y equals 48. And what I'm going to do is I'm going to solve for one variable in relation to the other. So it doesn't matter which one, but for this case, I'm going to solve for y. And to solve for y, I have to isolate it, meaning I have to get rid of this x by dividing both sides by x. So I get y is equal to 48 over x. Now, using this equation, I can plug this back into equation 1. So equation 1 is x squared minus y squared is equal to 28. Now here we got y is equal to 48 over x. So if I plug this in for y, I get x squared minus 48 over x squared is equal to 28. Now I can substitute the 2, so I get x squared minus 48 squared over x squared is equal to 28. Now I'm going to multiply both sides by x squared. So now, for my left-hand side, I have to distribute the x squared. X squared times x squared is x squared squared, or x squared to the power of 2. Now I have this minus 48 squared over x squared times x squared. These two x squared cancel out, so I just get 48 squared. And now this is equal to 28x squared. Now I'm going to subtract 28x squared on both sides. So I get x squared to the power of 2 minus 28x squared minus 48 squared is equal to 0. Now I'm going to set u equal to x squared. So I get u squared minus 28u minus 48 squared is equal to 0. And now I can solve this by completing the square. So I'm going to add 48 squared back. And now I get u squared minus 28u is equal to 48 squared. Now I'm going to add this, so negative 28, or we can say just positive 28. I'm going to add this divided by 2 squared on both sides. And if you guys don't know what completing the square is, you have to go watch a video on it. So I add this on both sides. I get 28 over 2 squared on both sides. And 28 over 2 is 14, so I get u squared minus 28u plus 14 squared, which is equal to 48 squared plus, again, 14 squared. And now the reason I did this, the reason I used completing the square, was because now I can factor this out. This turns into u minus 14 squared, which is equal to 48 squared, I'm going to rewrite as 50 minus 2 squared, and 14 squared I'm going to rewrite as 10 plus 4 squared. Now from here, u minus 14 squared is equal to 2500 minus 200 plus 4 plus 100 plus 80 plus 16. And now if we add these up, we get u minus 14 squared is equal to 2500, and if we take the square root on both sides, we get u minus 14 is equal to positive or negative 50. So we get two equations. Now we get u minus 14 is equal to positive 50, and u minus 14 is equal to negative 50. So u minus 14 is equal positive 50, I get u is equal to 64. And u minus 14 is equal to negative 50, I get u is equal to negative 36. Now remember how we let u equal x squared. So this means that x squared is equal to 64 and x squared is equal to negative 36. Well, we can't have a number squared equal to a negative number, so this is wrong, meaning that x squared equals 64 is my only proper equation, and if I take the square root on both sides, I get x is equal to positive or negative 8. So these are my two solutions to this problem. And I know that I said this wasn't work, but there actually is a way we can use this to find solutions, not real solutions, but imaginary solutions. So to do that, what I want to do is x squared is equal to negative 36. If I take the square root on both sides, I get x is equal to the square root of negative 36. And the square root of negative 36 is the same thing as the square root of 36 times the square root of negative 1. Now the square root of negative 1 is the same thing as I, so I get x is equal to the square root of 36i. And the square root of 36 is the same thing as positive or negative 6. So I get x is equal to positive or negative 6i. So these are another two solutions. And these aren't real solutions, but these are imaginary solutions, which still count as solutions to this problem. So my four solutions are x equals 8, x equals negative 8, x is equal to 6i, and x is equal to negative 6i.